Hello guys, in this video, we are going to learn some very important functions which we can use while we are using binary search. And just mark my words, these functions are really very useful, very important, will save your time to a great extent. Like there are many questions which if you start writing up the code, you will end up writing 20 to 40, 30 lines of code and still you can get some bug. But if you use these functions, you can write code them down in 2 to 3 lines. So, okay, let's start with these functions. The first one is binary search function. These are all inbuilt functions. Binary search function takes the starting address, ending address, and the target element. So what is the use of this function? This function tells us that whether the target element lies in the given array or not. So for example, suppose you have an array sorted like this 1, 4, 7, 9, and 10, and you want to find that whether element 9 is present in this array or not. So what you will do is you will apply binary search, initialize your starting index over here, ending index over here, find out the mid, then apply all the conditions which are there. But if you apply binary search and simply write this line, binary search, starting address will be the beginning. Let's suppose this is an vector. So, and vector of name ARR. So the starting address will be ARR.begin. The ending address will be ARR.end. And the target element is 9. So once you write this down, this function will return true for you. It will return true. So by using this one line code, you can simply check that whether a present element, a target element is present in this present given array or vector or not. Now this is like the time complexity of this code is same as that of binary search. That is, we go of log n, and it is a Boolean function, right? It will return true or false. If the element is present, it will return true, and if the element is absent, it will return simply false. Now the question comes is like, when we were able to do binary search in sorted array. Now sorted doesn't mean like it is only sorted in ascending order. It may also be sorted in decreasing order, right? Descending order. So what if the element is our array is sorted in descending order? Should we sort the array in ascending order and then apply this function? The answer is no. There is an inbuilt function by which you can apply this function simply on an descending order sorted element also. So if you see the function, it is something like this. Binary search, array.begin, array.end. The target element, let's suppose in this case it is 9. And just you need to add one thing, greater int. By adding this, you can apply this function in the array sorted in decreasing order. So this is for array sorted in decreasing order. So this is for the array sorted in decreasing order. So yes, this is a binary search function for you. Now, if we come to the other two functions, and these are the two most important functions. Like you can say in DSA, these are the one of the two most important functions, lower bound and upper bound. You will be using this many a times, lower bound and upper bound. Let's see the lower bound. You need to understand the definition of lower bound. It is like, if you understand the definition, you will be able to use this easily. So let's array is sorted in ascending order. array sorted in ascending order. If the array is sorted in ascending order, then lower bound function will simply return, this lower bound function returns the address of the smallest element less than or equal to target element. For example, let's say we have an array as 1, 2, 4, 7, 9. And if you apply lower bound on 5, like the target element is 5. So the lower bound function will give you the address of the element 7. Similarly, if you apply lower bound with target element 2, you will get the address of element 2. So if that particular element is present in that array, it will give the address of that element. And if that particular element is not present in that array, so it will give the smallest element which is greater than that element. For example, 5 was not present in this array, so it returned me the address of 7, which is the smallest element which is greater than 5. Similarly, if the array is sorted in decreasing order, it is not like कि खाली array sorted ascending order में sorted है तभी हम लोग ये सब functions use कर सकते हैं. Decreasing में भी अगर है sorted तो हम लोग use कर सकते हैं. Array sorted in decreasing order. So in this case, it will return address of the element, address of the smallest element, I would say. Address of the smallest element less than or equal to target element. In case of array sorted in ascending order, it was giving us the address of the smallest element, which is less, which is actually, I must say greater. I missed like this point over here. I wrote it wrong. It will give me the address of the element which is greater than or equal to the element. For example, in case of lower bound of 5, we were getting 7, which is the smallest element greater than 5. And in case if array is sorted in descending order, it returns the address of the smallest element less than or equal to the target element. For example, let's suppose the array with us is 9, 7, 6, 2, 1. And if we apply lower bound with target element as 4, so we will get the address of 2. Similarly, if we apply lower bound with target element 6, we will get the address of 6. So how we write these functions? Like we are getting the address, how to convert them to the indices. So the signature of the function is, if you look on the signature of the function, it is starting address, ending address, and a target number. So this is for the element sorted in ascending order. So if you look on the signature, like if you need to find out the element, so what you need to do is, let's suppose you have an address of 6. Let's suppose our array is something like this. The array is something like 1, 2, 4, 7, and 9. And let's suppose we have an address of 4. How can we find the index of 4? If we simply subtract the address of 4 with the address of 1, would we be able to find the index of 4? Like if the address of like one was suppose 400, then the address of 4 will be nothing but 402, right? Relative address if we talk about. Then once we subtract the address of 4 with address of 1, we will get the index of 4. So that is what we are going to do. If we code it down once, then it will be easier for you to understand. First, we can see the upper bound function and then we can code it down. So let's talk of upper bound function. The only difference between the upper bound and lower bound function is that in case of lower bound, if the element, the target element was present in the array, we were getting the index of that element. But in case of upper bound, we will only get the element which is greater than the target element, the smallest element which is greater than the target element, not if the element is present. For example, if our array is something like this 1, 3, 5, 7, 8, and suppose we apply upper bound with target element as 5. So the address, we will get the address of the element 7 and not the address of the element 5, unlike the case of lower bound. In case of lower bound, we were getting the address of 5, but in case of upper bound, we will get the address of element 7. Similarly, if suppose we apply the lower bound with upper bound with target element as 6, we will again get the address of index 7. So yes, this is the only difference between upper bound and lower bound, and you all will get familiar once we code it down. Let's code it down once. Like this is the element. This is the array with us. Let's suppose we find out the index of the smallest element, which is less than or equals to, let's suppose, 5 in this array. So ARR dot begin, ARR dot end. Let's suppose our target element is 5, and to find out the index, this function is going to return the address of that element, right? So to find out the index, we need to simply subtract it by the address of the starting element. So by this, we got the index. Now, if we print out the index of the element, so let's see what answer we get. So we are getting 8, right? Because the smallest element, which is less than equals to 5 in this array, 1, 2, 4, 8, 9 is 8. Now, similarly, if we apply like 4, so it is going to return me 4. 4 only because 4 is present in this array. Okay, so we got 4. Now, one thing which you need to keep in mind is, let's suppose if we found out if we find the target element as, if we keep the target element as 10. So what this function will do is, since the maximum element of this array is 9, and for 10, it should return the next element to 9, which is not present in our vector. So it will return the address of the like next element. Like once we do this thing, we find out the index. This index comes out to be n. This index comes out to be n. Why n? Because the next element to 9 is absent. So it took the address of the next element to 9 and it subtracted from the initial address of the vector. And so we got n. So in this case, if we try to access the element at that index, then we may get segmentation error or some garbage value. So to avoid that, what we should always do is, the healthy practice is that you should always check the condition that if the index you got is not equals to n. If this is the case, then you can easily access the element at that position. So this is what lower bound brings to you. Let's try the same thing if the array is sorted in decreasing order, 9, 8, 4, 2, 1. And for decreasing order, what we need to do is we need to add this thing greater int. The target element in this case, let's suppose it is 7. So the smallest element, which is the largest element, which is less than equals to 7, is basically 4. So the answer, which is less than equals to 7, is 4. So in this case, we should get 4 as our answer. And yes, let's check it. So we got 4 as our answer. Let's suppose the target element was 3. So let's check this one. We should get 2 as our answer, right? Yes, we are getting 2. Okay, so this is working fine. Let's code up the upper bound function once as well. So upper bound of 4 should be 2, like the smallest, the maximum element, which is which is less than 4. So it is 2. So yeah, once we can check that also. So yes, 2, we are getting 2 as our answer. And this is for the array sorted in decreasing order. Let's suppose the array was sorted in increasing order, and we applied upper bound over here with target element as our 4, then answer should be 8. Like the smallest element, which is greater than 4, is 8. So answer in this case should be 8. हाँ भाई, सही काम कर रहा है, 8 आ रहा है। अब एक और फंक्शन जो हमने देखा, बाइनरी सर्च, उसको भी थोड़ा देख लेते हैं, इसको क्यों छोड़। So let's suppose we do a binary search on this vector with, let's suppose the target element is 8. So it should return true. Let's see whether it's working or not. Okay, so it's working. The true symbol is like 1. 1 represents true. Similarly, if we like search for 5 in this array, let's check what we are getting. Okay, so we are getting false, that is 0. So yeah, that's the 3 most important functions for you all. Lower bound and upper bound is the one of the most important, like one of the most widely used function in data structures and algorithm. And like once you start using it, you will see that how fast you start writing your codes. Yeah, that's all for this video. Meet you in the next one. Thank you.